So this question is from IIT JAM 2021. Okay. So the question is based on maximum likelihood estimator. So let X be a uniformly distributed random variable in this interval, okay, where this A and B are unknown. The values of an independently drawn sample of size 5 from X are given by these. So the values are 1.3, 0.8, 9.5, 20.2, and 8.2. And this A hat and B hat are the maximum likelihood estimates for the parameters A and B, respectively. Then you have to tell that what will be these estimates. Okay. So for doing this, we'll first set up the likelihood function. So here we let the likelihood function be L, and there are two parameters here. Okay. So it is based on A and B. All right. So it will be equal to. So in this case, we have 1, 2, 3, 4, 5. Okay. We have five randomly drawn values. So it will be equal to x1, comma x2, comma x3, comma x4, comma x5. Okay. And the parameters are A and B. All right. So since these are independent, so I can write it as f x1 comma a comma b into f x2 comma a comma b, and so on till f x5 a comma b. Okay. Where basically this f xi comma a comma b, it is actually the PDF. It is the density function. Okay. So in this particular case, this likelihood function is actually 1 upon b minus a into 1 upon b minus a. Okay. 1 upon b minus a. These are 5 times. Okay. Because we have 5 random values. So it will be equal to 1 upon b minus a to the power 5. Okay. So now we need to maximize this. So for what value of b and for what value of a, this likelihood function will be this will be maximum. Okay. So we have to do that. So what we can do is I can take log both sides. All right. So log L will be equal to log of 1 upon b minus a, okay, to the power 5, which is equal to 5 log 1 minus log of b minus a, which is equal to 5 into 0 minus log b minus a. Okay. So finally it is equal to minus 5 into log b minus a. Okay. So I want to maximize this L. All right. So for doing that, I'll be differentiating this with respect to A and with respect to B. So let me first do that with respect to A. So it will give me minus 5 upon B minus A into minus 1, which will give me 5 upon B minus A. Okay. And when I differentiate it partially with respect to B, it will give me minus 5 upon B minus A. Okay. So notice that this likelihood function, this is increasing in A. So if as A increases, okay, this denominator will decrease, right? When this A increases, the denominator will actually decrease. And if the denominator decreases, then the whole expression increases, right? So, which clearly means that this is increasing in A. Okay. So, also notice that the x is a uniformly distributed random variable and all the values should lie in this interval. Okay. So that means each of these values have to be more than or equal to it, right? The interval is a comma b, okay, something like this. And these are the random sample drawn from this interval only. Okay, so they are somewhere here. Okay, so obviously each of them have to be more than or equal to a, right? So which means that all these values 1.3, 0.8, 9.5, 20.2, 8.5, 8.2, all of these have to be greater than or equal to a. So let me just initially call them x1, x2 up till x5. So a has to be less than or equal to x1. Okay, a has to be less than or equal to x2 up till a has to be less than or equal to x5. Okay, and since it is increasing in a, that means I need the maximum value of a. Okay, I need the maximum value that a can take. This thing is maximum del L by del A, okay, is maximum when A is maximum, okay. So what's the maximum value that A can take? We know that A has to be less than or equal to each of these values, okay. So let's say x1 is here, x2 is here, x3 is here, x4 is here, x5 is here, okay. So what's the maximum value a can take if this constraint has to be followed? I have to follow this constraint, okay. So obviously I'll be taking the minimum of these, okay. A will be equal to, a hat will be equal to minimum of x1, x2 up till x5. Why? Because basically I don't want to leave this gap. Okay. If suppose in this particular case, we know that the least value is x4, the minimum value is x4. In this here, if I take this as an example, let's say the x4 is the minimum value. Okay. But instead of taking x4, if I take a somewhere, even I take a even lesser than if than x4, then that means I am leaving these values. Okay. So basically I'm closing this space. All right. If I मैं एक ऐसी वैल्यू ले रहा हूँ ए की जो इसको बाइंडिंगली सेटिस्फाई कर दे इस कंस्ट्रेंट को, मैं उससे और कम जाऊंगा then I am taking even lesser value. Okay, if I go even beyond the minimum of this, so that won't be the maximum. That won't be the maximum value that a can take. The maximum value then that a can take is exactly equal to the minimum of all of these values. Okay, similarly, notice that here this expression is decreasing in a. Okay, so if this is decreasing in a, then my likelihood function L will be maximum when B is minimum, right? क्योंकि ये decreasing है in B, okay? जैसे जैसे B increase करेगा, this likelihood function will decrease, okay? So that means I should be taking the minimum value of B. So L will be maximum when B is minimum, okay? So मुझे B की वो value निकालनी है, the minimum value that it can take, okay? So what is the constraint? So obviously all these sample values have to be less than or equal to B. Okay. So B has to be greater than or equal to x1, x2. B has to be greater than or equal to x3 because all of them will lie in this interval. So all of them have to be less than or equal to B. Okay. So B has to be more than or equal to x4 and B has to be more than or equal to x5. So this constraint has to be satisfied. Okay. So it's something, the situation is something like this. So let's say x1 is here, x2 is here, x3 is here, x4 is here, x5 is here, okay? And B has to be more than or equal to each of these values. So what should be B? What is the maximum value that B can take, okay? Such that this constraint is satisfied, okay? So obviously it has to be the minimum if B is greater than or equal to each of these values. Okay, तो मुझे B की मिनिमम वैल्यू चाहिए, राइट? So if I want B to be as I want B to take the minimum value possible, okay, and B is greater than or equal to each of these values. Okay, so basically B is greater than or equal to max of x1 x2 up till x5, right? Basically it is another way of writing this calculate. B इन सबसे बड़ा है, यानी B इनके मैक्सिमम से भी बड़ा होगा, राइट? सो तो B की मिनिमम वैल्यू क्या होगी अगर B इन सबसे ही बड़ा है? ओके, B के लिए आपके पास पॉसिबल वैल्यूज हैं, ये B हैज टू बी ग्रेटर देन और इक्वल टू ऑल ऑफ दीज वैल्यूज, विच मीन्स B इज ग्रेटर देन और इक्वल टू द मैक्सिमम ऑफ दीज. तो B की मिनिमम पॉसिबल वैल्यू क्या हुई? तो B की मिनिमम पॉसिबल वैल्यू हो गई ये वाली, राइट? सो दैट मीन्स B इज equal to the maximum of x1 x2 up till x5. Okay, so आंसर क्या होगा? यानी a hat will be the minimum of all of these values and b will be the maximum of all of these values. So a hat will be the minimum of all of these is zero point 0.8 and b hat is the maximum of all of these values, which is 20.2. Okay, so answer is a. All right.